Hello friends, welcome once again to ASOM Novel Online Math class. Today we are going to continue with our works on partial fractions, and our center of attention today is on the nonlinear factors that are not repeated in the denominator. When you talk about nonlinear factors, it means that one of the factors in the denominator must be quadratic or cubic or any other polynomial more than linear. That is, the highest power there should be up to 2 or more than 2. That is the case here. Supposing you have something like 2x minus 1 all over, let's say, x plus 5 into 2x squared plus 3x minus 1, something like this. If you want to split a term or an expression like this into partial fraction, you can see that one term here, one expression here is quadratic, is having a power of 2. Therefore, it is nonlinear. That makes it nonlinear. And again, it is not repeated in the sense that you don't have an external power of 2 here, or 3 or 4, as the case may be. Because if you have a power there, it means it's repeating itself. That is what we meant by it's not repeated. That is the category we are going to discuss today. But in this particular video, I'm not going to solve any problem at all pertaining to partial fraction. But what I'm going to clarify you on today is on how to break it down. For example, now I have 2x minus 1 all over x plus 5 into 2x squared plus 3x minus 1. If you want to split this into partial fraction, you have to call it a all over. The first expression here is linear. Okay, that is why I'm having a here. When you have a linear factor here, this should be a constant a. So you repeat x plus 5, but this is a quadratic factor down here. Therefore, I have to use a linear factor in the numerator. When you have quadratic, you are using linear. If you have linear, you are using constant. If you have cubic, you are using quadratic in the denominator. You get? And remember, the general form of a quadratic equation, you have quadratic. The general form is ax squared. Let me use capital letter. Ax squared plus bx plus c. If you have linear, you shall have bx, or rather ax plus b, or bx plus c, as the case may be. This is the form of linear. Then if you can have a constant can just be a letter a or b or c, as the case may be. Assuming I have something more than quadratic, let's say cubic expression will be of the form ax cubed plus bx squared plus cx plus d, something like this. The letters may change, but this is the pattern it will follow when you say that this something is cubic, the highest power of 3. If you have a quadratic equation that has a power of 4, you can have ax squared, as power of 4, plus bx to the power of 3, plus cx to the power of 2, plus dx plus e. This is when you have a quadratic equation having a power of 4. This is how to split it down. Now, what I'm trying to emphasize here, what I'm trying to clarify very well here is that when you have something linear, the first factor here is linear. Therefore, I'll use constant, because constant is directly above linear to represent it. But when I have quadratic here, I'm going to use linear, because linear is directly above quadratic. Assuming this is cubic, look at cubic here, I'll use quadratic on top. If I have quadratic, I'll use cubic on top. So because I'm having a quadratic expression here, quadratic, I have to use a linear expression to represent it in the numerator. Okay, it must be 1 less than the power. So this will now be, I have used letter a. Look at linear here. Instead of using ax plus b, I can use bx plus c, because letter a has already been used here. So coming here, I will call it bx plus c all over 2x squared plus 3x minus 1. This is how it will look like. Then you continue the process of making it splitting it into partial fraction, which we are not here to discuss. Supposing I have 2x minus 1 all over, let's say x minus 3 into 3x cubed plus 5x minus 2, for instance. If I have something like this, this is a cubic expression. So I'm going to split it into, the first one is linear. So this will be a all over x minus 3 plus, coming here, this should be b all over 3x. Sorry, here I'll use this shouldn't be b because this is cubic, so I'll use quadratic, and quadratic is ax squared, but a has been used, so I'll start with b, bx squared plus cx plus d all over 3x cubed plus 5x minus 2, for instance. And finally, assuming you have something like let's say 2x minus 1 over, this thing can change, it can be any value, let's say 2x plus 5 into 3x squared plus 5x minus 1 into 2x cubed plus 5x minus 7. Let's say you have something like this. You've now seen that the first one is a linear factor, so I'll use a constant on top. I'll use a all over 2x plus 5. Then for this one, this is quadratic, so I'm going to use linear. When we have quadratic, we are using linear. I have to use linear, will now be bx plus c all over we have 3x squared plus 5x minus 1 plus, this is cubic, and because this is cubic, I'm using quadratic. Quadratic is I've used a, b, c, so I'll start with d. I'll now have dx squared plus ex plus f all over 2x cubed plus 5x minus 7. This is what you are going to simplify to put something like this into partial fraction. A clear understanding of this will go a long way, helping you to combat with problems you may face under partial fractions. Expect a video soon under this particular category, non-linear factors that are not repeated, which are solve problems, so that you understand actually how problems are tackled.